Okay, electrolysis, here we go. So, electrodes are placed in three different solutions, J, K and L. A 6-volt direct current source is connected to the electrodes. Any products formed at the electrodes are identified. Right. Explain which solutions are electrolytes for 2 marks. Okay, well, an electrolyte is quite simply a solution that can conduct a current. So, solution conducts electricity? Yes, J, yes, K, no L. So it's J and K, okay? Those two are electrolytes. Now, this is a 2-mark question, so it says explain which solutions are electrolytes. So to get 2 marks, you have to say J and K, and you get the 2nd mark for saying because they conduct electricity. Okay, good. Which material is most suitable to make the electrodes for the electrolysis of a dilute acid? Right, so the options are zinc, sulfur, iron and graphite. Right, it's the electrolysis of a dilute acid, okay? And you just need to know that when you're electrolyzing a dilute acid, the electrodes do not react with anything in the solution, okay? For the electrolysis of dilute acids, you need inert, in other words, non-reactive electrodes, okay? So we're looking for the most non-reactive of these 4, and well, it's graphite, okay? Graphite is just carbon, right? And zinc, sulfur and iron, they're all more reactive than carbon, okay? So for electrolysis questions, okay, it's a large topic in the sense that there's lots of different things you can electrolyze and they all have subtle differences between them. So I'm afraid you've got quite a lot of work to do to revise and learn electrolysis well, okay? So you just need to know that if you're electrolyzing a dilute acid, then you need, it's one of the electrolysis examples where the electrodes don't react, you need them inert. And you also need to know your reactivity series. I've got a video on this, I've got videos on this, and carbon is less reactive than iron, sulfur and zinc. Good, okay, let's move on. When a solution of sodium sulfate is electrolyzed, the products formed at the electrodes are hydrogen and oxygen. Explain the formation of the products at the electrodes for 4 marks. Okay, so let's have a colour change, why not? We're electrolyzing sodium sulfate. Okay, so we have, which side should we have positive? Let's have this side positive. Okay, so we've got this situation. Well, this is negative, right? This is positive. Right, and this is our sodium sulfate solution. Our negative electrode and our positive electrode. Okay, negative electrode is called the cathode, positive electrode is called the anode. If you can't remember that, just write negative electrode and positive electrode in the exam. Okay, so we've got sodium sulfate, which means we have sodium. So sodium sulfate is Na2SO4, okay? It's 2 sodium ions stuck onto one SO4 2- ion. So there's your sulfate ion, which has a 2- charge, and each of those has a +1 charge. The sodium ions, and there's 2 of them. Okay, so the point is we've got sodium ions in the solution. We have SO4, the 2- charge ions in the solution. But you also need to know that, like I said, you've just got to learn this. For this particular electrolysis, sodium sulfate, the interesting, well, I hope you find it interesting, bit is that there are hydroxide ions in the solution and hydrogen ions in the solution. Okay? And it's actually these that do the interesting stuff at the electrodes. Okay? Not these, in this particular electrolysis case. So, let's get back to the question. You have to explain the formation of the hydrogen and the oxygen at the electrodes. Okay. So, first thing to say is that there are sodium sulfate, hydroxide and hydrogen ions in the solution. Okay? Next, a little drawing as well, won't do any harm. You can quickly draw this. The positive ions are attracted to the negative electrode. Okay? And the negative ions are attracted to the positive electrode. Okay? So write that. Again, I'm doing it shorthand, but you have to write full sentences. So the sodium and the hydrogen are attracted to the negative electrode. Okay? And the sulfate and the hydroxide ions are attracted to the positive electrode. Okay? Now, I'm going to change colour because this flaming pen's running out of ink. Now you need to know what happens at the electrode. Like I said, and you don't really need to know the details of this, just remember what I'm telling you now. It's actually the hydroxide ions and the hydrogen ions that do the work. So, which one should we do first? Let's do the negative electrode first. So, at the negative electrode, you have the hydrogen ions being attracted to it, okay, like we said, and hydrogen gas is formed. So we know that H2 is being formed here, and we also know that O2 is being formed there. They actually told you that in the question, okay? But you should remember, know that anyway. So, the negative electrode, how do we get H2? Well, the negative electrode is loaded full of electrons, okay? It's negatively charged. So, you've got hydrogen ions plus electrons coming together and making hydrogen molecule. Now, hydrogen molecule is 2 hydrogen atoms bonded together, covalently bonded, so it's H2. So we need to balance it. So if there's 2 hydrogens, we need 2 hydrogens and 2 electrons. Okay? And that's it. You need to know that that's how hydrogen is formed at this electrode. 2 electrons from the electrode jump onto the hydrogen ions and form a hydrogen molecule. Okay? At the positive electrode, okay, it's a little bit more complicated, and again, I'm sorry, you've just got to remember this and learn it. It's OH going onto the electrode, and somehow we're getting O2 out. So how does that work? I'll go for the numbers as well from the beginning. It's actually 4 hydroxides, okay? It makes a single oxygen molecule. The oxygen molecule, like hydrogen, is O2. There's two oxygen atoms make one oxygen molecule. It's a single bond for hydrogen, double bond for oxygen, but that's not relevant for this question. Okay, and it also makes 2 water molecules, and it gives up 4 electrons. Okay, remember that right now, that equation. Okay, so that's what's going on over here. The 4 hydroxide ions hit the positive electrode. Okay, 1 molecule of oxygen is formed. Also 2 water molecules are formed, they stay in the solution, and 4 electrons go into the electrode and flow around in this direction. Okay, let's just check it's balanced. 4 oxygens on the left, 2 there, 2 there, yes. 4 hydrogens on the left, 2 times 2 is 4 there, yes. 4 electrons on the left, 4 electrons on the right, yeah, it's correct. Now, that will get you your 4 marks, okay? The question was, explain the formation of the products at the electrodes. Like I said, you do have to write it out in full sentences, but as well as the sentences in the English, okay, write these equations, get them down too. And saying a little bit extra won't do any harm. I would also just add, you can say that the electrons, because you will have written that the 4 electrons go from the hydroxide into the electrode, and then say that the electrons flow round or flow from the positive electrode to the negative electrode. Okay, the electrons flow in this direction. And that's it, that'll get you the 4 marks. So, like I say, I'm sorry, but you've just got to learn and understand these equations, what's going on here and here. Okay, right, final question. Copper is purified by the electrolysis of copper sulfate solution using an impure copper anode and a pure copper cathode. Write the half equation for the formation of a copper atom from a copper ion. 2 marks. Okay, well, all that's junk they told you at the beginning, copper is purified by electrolysis and blah blah. It's only 2 marks. You don't need to go into all this again. Luckily, I mean, you should know, like I said, you have to learn the particular electrolysis cases. You should have learned the case of copper electrolysis and from a copper sulfate solution. So go learn that now as well, okay, as well as this, as well as all the other electrolysis things such as dilute acids and aluminium and all that sort of stuff. But the actual question says, write the half equation for the formation of a copper atom from a copper ion. So all that stuff at the beginning is kind of irrelevant. It just wants the formation of a copper atom from a copper ion for 2 marks. And you can do that whether you know the electrolysis or stuff or not. Okay, formation of a copper atom from a copper ion. Well, you do need to know, well, let's hope there's enough ink in this, that copper forms a 2+ ion, okay? it can form a 1+ ion. Let's not go into that now, okay? For these sort of questions, just go with copper as a 2+ ion, okay? So if it's 2+, it has to gain 2 electrons to form a copper atom. Okay? 2+, 2- cancels out, no charge. That's it for 2 marks. That's a copper ion, copper 2+. If it's got a 2+ charge, it needs 2 electrons to turn it into a neutral copper atom. Okay, 2 marks. Good. And that's it. Finished.